Okay, so as introduced, this is Gülşah Hilan. I work at the Unitelma Sapienza University of Rome. We are the coordinator of this SUSTRAC project. I kindly ask you to mute yourselves if possible during the meeting, or later on we will open the floor for questions and discussions. We will have the space for everyone. So now I'm sharing my screen in a second, and I assume you will be seeing it in the presentation mode right now. Okay, good. So a very brief introduction from my side. First of all, what is the objective of this workshop? This is the last workshop of our design conference series. And we want to present an overview of the selected value chains from our side regarding the plastics sector first. And we will provide process description, market information, and relevant policy instruments. This will be the starting point for the discussions. And we want to be inspired by specific case studies directly from the experts' side. So we have invited speakers with different perspectives and with different backgrounds, so that they will share their perspectives, good practices, and challenges and or barriers they have been facing in the transition from linear to circular economic model. And finally, we will discuss three dimensions, which are policy, environmental and societal, and finally economic dimension, and to provide recommendations for the transition in the plastics sector. And what we expect from this workshop is also threefold. We want to provide actionable knowledge in terms of inspirational good practices, challenges, barriers, and recommendations in the sector. And we want to collect additional information to our ongoing SUSTRAC research, such as identifying relevant indicators, identifying data gaps, or checking data availability with the stakeholders. And finally, to co-create tailored policy recommendations, paving the way for future policy developments at different levels, such as regional, national, or European. And today we have a very full agenda. So this is the opening and welcoming also from my side. Later on, we will hear an inspirational pitch from our invited expert from Plastics Europe, giving a brief introduction of the pathway for the plastic sector transition. And then we will move to our case study, the first one, polylactic acid. We will first introduce case study of SUSTRAC, and then we will have invited speakers from NatureWorks and Taglev Industries. And then we will have another inspirational pitch session about bio-based polymers. And then we will move to SUSTRAC case study, which is polypropylene from used cooking oil. And finally, we will open the floor for an interactive session using Miro board and to further discuss the three dimensions: policy, environmental and society, and economic, including all the participants' views, perspectives, questions, and the topics that they want to bring. And finally, we will close our workshop in 1.5 hours, more or less. And now the quick introduction of our project for the ones who are here for the first time with us. So SUSTRAC reads as supporting the identification of policy priorities and recommendations for designing a sustainable track towards circular bio-based systems. We started working in November 2022, and this is a 3-year project, which is also a coordination and support action. This is why stakeholder engagement is at the very core of our project. So this is also why we are organizing many events to include stakeholder input. And a few keywords from the abstract. So we start with the underlining the need for this transition from linear fossil-based systems to circular and bio-based ones in order to identify the opportunities to reconcile sustainable long-term growth with environmental protection. But at the same time, we need a critical assessment of all related impacts of both linear and circular economic models in order to identify the policy priorities. So based on this background, we aim at supporting policymakers to develop sustainable pathways to replace the traditional fossil-based systems with sustainable circular and bio-based ones, and at the same time contribute to achieving the European Green Deal's objectives. And at this moment, I would like to encourage you to visit our website and to check our social media profiles. We use them very actively in order to promote our events or also share our findings during our course. And main and specific objectives, as you can imagine now, we have two main objectives, such as providing knowledge and tools for monitoring and assessing the impacts related to linear and circular systems, and to define and identify policies, priorities, and support policymakers to promote the sustainable transition at different levels, such as European, local, or cross-territorial value chains. And we have 5 specific objectives that we use as stepping stones to reach the main objectives. The first one is to identify, assess, and prioritize the different types of limits of linear, carbon-intensive, and fossil-based economy, which we already completed in the first half of our project. And the second one is to develop knowledge and tools for monitoring and assessing the impacts. The third one is to assess the environmental, social, and economic impacts of the sustainable transition via using case studies, so that this series of workshops is organized under this specific objective in the first place. And then we will use the information to create, simulate, and interpret a variety of scenarios using a system dynamic modeling for the sustainable transition. And finally, all the knowledge gathered will help us to identify policy priorities and define corresponding policy actions to provide recommendations. So just a snapshot of our first research results. We checked the barriers for this transition from linear to bio-based economic, circular bio-based economic model. So we saw that the problem is already very complex, and we divided the barriers into different clusters, such as cultural, economic, environmental, governance, structural, and technical. Just to name a couple of them related to the plastics sector, but also it was seen that the barriers are reoccurring across different sectors as well. For example, the environmental barrier, lack of harmonized methods for environmental, climate, and sustainability impact assessment is one of the most relevant barriers identified, or such as an economic barrier of high investment costs and risks for establishing circular bio-based industries stand out again as the most prominent barrier. And with this overview, I would like to finish my part to leave the floor for our pitchers. And also thank you again for being here. I hope you will enjoy the meeting.
Thank you, Gülsa, for this great overview of the project and of the day. Before going in deep into the pitches, as Gülsa was saying, I ask you to take your cell phone or your laptop, because we want to ask you a question: which category of stakeholder you belong to? So if you scan the QR code with your cell phone that you see on the screen, you will enter Mentimeter. Otherwise, you can also use your laptop writing menti.com, and using this code you can read on the slide. So the code is 21985458. Menti.com. So I will leave you some seconds to entering this game. So we want to break the ice a little bit. So asking basically if you are a researcher, if you are from industry, if you are from an SME, an NGO, if you are a policymaker, or if you belong to other categories. So menti.com 21985458. So I think you, Luis, can start collecting answers. So as already said, we are asking what kind of stakeholder category do you represent? So last days, during the last 3 workshops, we had quite a good balance between researchers and industries, both big industries and SMEs. Let's see today how it goes, with some representatives also from NGOs and CSOs. I think that also today the situation is very similar to what we observed in the last workshops. So we have a good balance between researchers, industry. No policymakers, but this is expected. We will host them during our plenary conference in September. I will give you more details about this conference at the end of the workshop. So great to see that we are very balanced also today. And so with this, I think we can move on to present our first feature. So I leave the floor to our experts from CIRSE to present our first features from Plastics Europe.
Okay, now Irene Mora going to represent the Plastics Europe, and she's the lead of Public Affairs and Sustainability Department. And if Ines Grons is going to present the industry roadmap. So Irene, if you want to share your screen.
Okay, thank you very much. So let me know when you see my screen.
Now, yes.
Can you see my screen?
Yes.
Okay, thank you very much for inviting us to participate in this workshop. I'm Irene Mora. I work for Plastics Europe in the office of Iberia, which covers Spain and Portugal, but Plastics Europe, and I would like to present in a very nutshell, because I only have 5 minutes. I will try to make it fast. The roadmap that we present as an industry last year, called the Plastic Transitions. Just one slide for those that don't know Plastics Europe. Plastics Europe is the European association that represents the plastic.
Sorry, Irene. Sorry, Irene. Yes, to interrupt you, because we don't see the presentation. We see just the first slide. We don't see the second one. So maybe you want to share the whole screen, so it's easier. Okay, because we don't see slide changing.
Okay, sorry. Let me. Can you see now?
We see the third slide. Try to change a slide. We don't see the presentation mode, but anyway, it's okay. Just to understand if you change slide, that we see.
Can you? I'm changing a slide. Can you see?
No, we see just one slide. I may suggest to share the whole screen, not the window, because sometimes sharing only the window may give some problems.
Okay, sorry for this.
No worries.
Okay. Try again. Can you see now?
I think same as before. If you change slide, I don't know, Carlotta, maybe you have the backup and you can share.
Yeah, I sent the presentation this morning to Tirce. I don't know why, because I'm sharing the presentation. I can see how the slides are passing by, so I don't understand why you can't. So Carlotta, will you share the presentation for me?
Yes.
Okay, thanks. Sorry for that. So, well, in the meantime, I will present Plastics Europe so we can save time. So Plastics Europe is the pan-European association that represents the plastic raw materials producers. So we represent all the companies that produce plastics, either though they came from virgin materials, but also from circular plastic that you will see. So you can pass this slide, please. So before presenting, so we are based in Brussels and we have a regional office all around Europe. You can pass this. So I just want to share a few key numbers to understand the overall situation at European, but also at global level. I don't know if all the data and all the reports that we publish are available in our website, either in English and also in other language. So all the links are in the presentation, so you can share the presentation afterwards with the participants. So I know this is based on bio-based polymers, but I wanted to highlight the last data that we have from a global perspective of the plastic productions. So what happened, this data has been published a few months ago, and the data are from 2022. So what we see is that the global rate of plastic production in Europe is now 40%. And what is a little bit worry is that since 2002 and 2022, which means in 20 years, the rate of plastic production in Europe has decreased from 28% to 14%. Why I say this? Because at global level, the plastic production has been rise, but the competitive of Europe is getting worse and worse. And this is something that I wanted to also to highlight, because it also has to do with what's going on with the plastic industry in Europe. So, and also for the first time, we published also data from bio-based and bio-attribute plastic productions by regions around the world. The last data that we have is, is a very low data. It's only 2.3 million tons in 2022. But after China, Europe is the second producer of bio-based plastics. So next slide, please. I can hear some noise, so I don't know if you can mute your microphone. Thanks. So and also a few months ago, we also published this report, which is the circular economy for plastics, and for the first time, we introduced European and national productions that include circular plastics. What we mean for circular plastics is all those plastic that has been produced using recycling plastic, either from mechanical or chemical, but also from bio-based plastics. Here you have the link to the reports. And we have included also a deeper analysis of the waste management by application sector, not only packaging. Before we were focused more on in packaging, but now we include other sector. And also for the first time, we use the new calculation method that comes from the packaging waste directive from 2028 that give us a new point for measuring the recycling date. So we apply this new methodology not only for packaging but also for all the other applications. So we in the past we have a report of 20 pages, and now this report is 100 and something pages. So it's a much deeper report with a lot of data for circular economy for plastic. So just for you to know. Next slide, please. And now in the next two slides, I just highlight some key figures from this report. I can pass through this. But I just wanted, because I don't know if people know this report, but it's a very, very interesting report, and I wanted to highlight. So you can pass this. Oh, here, sorry, here I wanted to show the evolution on the plastic productions on the different origins. So you can say in gray the evolution in the production of fossil-based plastics, and you can see that is slightly going down since 2018, while all those circular plastics came from mechanical, chemical, and also a little bit of bio-based is slightly getting up. So the tendency is each time plastic producers are less dependent on fossil-based materials and going through the direction of produce much more circular plastics. Next slide, please. So in this sense, what we did last year. Okay, so last year we present the roadmap of the plastic European industry and what we did now. You can go to the next slide, please, Carlota. So we start from a report called Reshaping Plastics that was published in 2022 by a think tank called Systemic. This think tank works for European commissions and also other entities. And this report show different roadmaps to achieve circularity and net zero ecosystem for the plastic industry in Europe. So the conclusions of the report is that the industry is adapting, but not fast enough. So we need to increase collaboration with value chains and political decision makers if we really want to achieve the target that we want. So what we did is, as part of the result of this study, last year, our member companies and together with Plastic Europe, we published our roadmap that is now our North Star. We say that is the guide that we have for the next year and how to achieve circularity and net zero in 2050. So in this roadmap, next slide, please, Carlota. So this roadmap is based in a vision that we want to be part of the solutions to enable a sustainable future, and has 3 pillars. One focus on circularity, one focus on net zero, and one focus on the sustainable use of plastics. So in these 3 pillars, we can go to the next slides. So what we want, if we identify different levers to make plastic circular by different levers, we identified also different levers to help and drive life cycle emissions to net zero by different approach. And also we foster the sustainable use of plastics. This report is a huge report, so I only have 5 minutes to present, but in the roadmap is identified. I didn't mention, but we prepared this roadmap together with Deloitte that help us in the to see the provisions in those 3 pillars, and also identifies not only the different actions that had to be done by the industry, but also different policy asks at short, medium, and long term to achieve all the targets that we present in this roadmap. Next slide, please. So in the first pillars, when our goal is to make plastic circular, we have calculated that circularity is possible, but it's very ambitious. So the estimation is that for 2050, you can see what we have calculated in the production of circular plastics. So we from 2021 and 2050, we expect that in the plastic production for virgin material will go down from 50 million tons that we are producing now to 22 million tons, and the rest will be covered by either reuse applications, that is the first on the top. We expect that 12 million tons of plastic will be reduced by using reuse applications. We expect mechanical recycling to keep increasing since it's the more mature technology. So we expect more and more mechanical recycled plastic to be used as new materials. We also expect an increase in chemical recycling, especially after 2030. I don't know if you know this new technology, but this new technology is starting, but our member companies has published a huge investment on chemical recycling in Europe, and they expect that it will grow exponentially from 2030 until 2050. Regarding plastic made from biomass and biopolymers, we also expect, which is the red one, we also expect an increase, and it also will play a role in the circular plastic that we want to produce for 2050. In the case of carbon capture and utilization to use to produce polymers, this is a technology that still is much more immature. So the increase that we expect is much lower, but still we have a small contributions to our targets. So this is in a nutshell the first pillar. The second pillar, next slide, please.
Sorry, Rene, please come to an end because it's already 10 minutes and we have a very dense agenda. So I kindly ask you to go through the conclusion.
Yeah, I will have 1 more minute, promise. So the roadmap also shows how all of these measures will reduce the net zero emission by 2015. So you will see the different contributions to different measures. And then in the next slide, in the roadmap was also calculate how much this transition for the plastic industry will cost. So the conclusion is to transition to a circular and net zero system will cost 2,035 million euros. Next slide, please. And here you have also the main takeaways from this roadmap. And at the end of the presentation, you have a link to much more information. We have a specific, well, it's the previous one, sorry. Here, we have a specific hub in our website for all of this roadmap with executive summary, Q&A, and more and more and more, and the full report. So you can download here all the information. Sorry for my delay, and thank you very much.
No worries, Irene. Thank you very much for the very interesting presentation. So I think this gave an overview really of the sector, how it's moving towards sustainability. So thank you very much. We will collect questions. If you have questions for Irene, please write them in the chat. And now I will leave the floor to Luana Ladu from BAM for introducing the first Sustra case study, so the polylactic acid case study. Luana, the floor is yours.
Yes, good morning, everyone. Can you see my screen?
Yes.
Yes, in presentation mode. Yes. So my name is Luana Ladu. I work for the German Federal Institute of Material Research and Testing, and I will provide you a brief introduction to one of the case studies. As you know, as Gulsa said, we have a case study approach in our project, and one of them is a PLA. And I will provide a brief overview to it before we go to the pitches. So PLA is a bio-based polymer, biodegradable under certain conditions. And it is the building block is the lactic acid, and coming usually from fermentation of carbohydrates. And the value chains of the PLA has different steps, starting from the feedstock production and use. And you can use different kind of feedstock, can be first generation, second generation, or third generation of feedstock, as we can see in this photo, in this figure. And then we have the raw material production through fermentation usually, and then this will bring us to the production of intermediate product or lactic acid. And then through downstream stages of polymerization, usually we have different end products of PLA, can be used, for example, for consumer goods, for packaging, flexible packaging or rigid package, but also, for example, for agricultural films, mulch film, for example, and many other applications. I took this photo, first of all, from the report of the European Bio-Based Plastic. We can see that it is expected, currently almost 21% of PLA, of bio-based plastic globally is PLA, and it is forecast to grow to 40% by 2027. And as we can see in this photo from Nova Institute that was recently published, we can see the statistics that PLA is a big share in the production of bio-based plastics. And regarding the stakeholder mapping, so different stakeholder, category of stakeholders are involved in the production of and in the value chain of PLA. We have, for example, we can see in the bioeconomy supply chain, we have, as we said before, different feedstocks and related stakeholders, but also in the different steps of the value chains, we have different for example, producers, suppliers, and so on involved. And also for the end of life, we have different stakeholders. And we have also from the government level, of course, the government are very, very important policymakers to design or to establish the right condition for the production of and future market uptake of PLA, for example. And we have also different stakeholders involved from academia, researching, for example, different production of PLA, but of course also the industry is very, very important, and the civil society. So we have seen different categories of stakeholders involved in the PLA production. And regarding the policy environment of PLA, we are very, very important to see with a variegate policy environment, starting, for example, from the EU bioplastic strategy and the EU bioeconomy strategy. They provided already some inputs for the further development of PLA. And of course, also the Green Deal with the different successive legislation also provided environment for the sometimes some challenges maybe, but also like was as an influence on the PLA production. In particular, also the new Circular Economy Action Plan. And as we can see here, also very important is the policy framework for bioplastics that was launched in 2022. That is focusing mostly on on the sourcing, labeling, and using of bio-based, biodegradable, compostable plastics. And briefly about indicators. So of course, as all the bio-based plastic, all the products sustainability should be proven. We can see that for PLA, we identify different indicators, and somehow there is also some challenges. For example, there is some idea of this land use change by producing PLA. Of course, the European Bioplastic Association doesn't support this, because they say there is not really this land use change for PLA production. And there is also other indicators, for example, the biodiversity, because PLA microplastic could pose challenge in the ecosystems, or water consumption, or also, for example, energy and chemical use. There is also some relevant economic indicators. It's very important, for example, to make sure that we have the right infrastructure also for the end of life of PLA. And also it's very important to estimate what is value added for the bio-based economy sector, also looking at the cost of production and the return on investment. And it's also very important, of course, to increase the public awareness, and because sometimes there is many confusion, for example, between the terms of plastic, bioplastics, PLA, and so on. And it's also, for example, very important to respect different social indicators also in the production of the feedstock, of course, but also of the PLA itself. Now I will give the floor to the first pitch. Is Natur Works that produce PLA. Unfortunately, TAGLIF, they are present here today, but there is not a presentation from them, but they will provide inputs in the interactive section that we follow today. And then we have Amimova. They produce starch-based polymers, so they have also similar challenges linked to PLA, and also said that they produce acetate. So I will give the floor now to Maria Giovanna. Thank you. Maria Giovanna, she will share a screen, correct? Yes. Thank you.
Thanks to Susanna. Susanna, to Anna, sorry. So Maria Giovanna is here. I'm not sure.
Yes, she's here.
Yes, okay.
Maria Giovanna?
Otherwise, we can switch the order, because I'm not sure I'm seeing her in the participants, so maybe she's having some troubles connecting or speaking.
Okay, so we can give the floor to, as I said, TAGLIF doesn't present, so we have, I would say, Aminova.
Okay, yes.
Thank you.
Shall I share my screen?
That would be great. Thank you.
Yeah. Ooh. Oh. Okay, can you see my screen?
Yes, not in presentation mode. I don't know if you want to try, Catherine, putting in presentation mode.
If you would be all right, this way would be perfect, because I realize I have a second screen and it always switches if I go into presentation mode.
No worries.
So I'm sure there's a solution for that. Okay. All right. Yes, so coming from Aminova Polymers, yes. And we are, so just a quick introduction on what we do as a company. So just to give you like a quick idea where we're coming from and what our point of view is, and to tie into the bigger pictures. So, so you can see the slides changing.
Yes, Catherine.
Perfect. Okay. Yeah, so Aminova was founded in 2012, and so we started out as like a startup, but I think we're not technically a startup anymore, because we've reached our point even, and by now we're 17 people working at Aminova. We have our own production facility, we have our own R&D division, and yes, we are located in Germany. So we have our production facility in Bitterfeld-Wolfen and our headquarters close to Leipzig. So here in central Germany. And so what do we do? So we have developed a starch-based biopolymer family called Amylofol. So we produce those biopolymers at our own production facility, and the polymers are film formers and rheology modifiers, and our main application is in agriculture and also soon in cosmetics. And our polymers are bio-based and biodegradable. And so as like a small company with a new product, we have some challenges that we face in bringing those products to the market and establishing sort of a bio-based alternative to fossil-based products that are now on the market as conventional polymers. So in general, I think in chemical industry, the time to market is rather long. So compared to other industries, one needs more capital, more investment is required to establish the product in the market, and this can make innovation more difficult. And I think one of the reasons for that is really is regulation as well, because of course in chemical industry there are more risks attached to producing something with the chemicals involved. So currently our topic is we would like to build a new production site to produce our bio-based polymers. However, in Germany, that's rather difficult with the current regulation in place to find a site that's suitable and to actually fulfill all the criteria required. So scaling up is not that easy. And then there's a second topic associated with biopolymers in general, I think, and that's the assessment of biodegradability. So, I mean, one part is, okay, having a circular economy where you recycle things, but with the biopolymers that we have, recycling is not really the idea, but biodegradation, especially in agriculture, is more of a topic. And of course, there's a lot of certification involved there. And so, for example, what we struggle with is that all certification schemes that are in place at the moment focus on the full degradation of the polymers. So the certification scheme is really focused on, okay, how much CO2 is formed when the polymers degrade. Because of course, with most conventional plastics, when they come into the soil or into water for degradation, for example, wastewater treatment plants, you don't want to have any like toxic intermediates such as microplastics. So of course, you really want them to degrade completely, and that's what you judge in the end. But with biopolymers, they do not form any toxic degradation products. Like for example, with starch, the basis that we use for our biopolymers, they just form oligosaccharides, like little microorganisms, just sort of cut them up into smaller chunks, but the chunks themselves are not toxic, as for example with microplastics. And with lignin, this is a similar topic. Lignin just decomposes to humic acids, which are quite beneficial for plants or for the environment, but however takes a very long time until it actually forms CO2, and that means that you can't really get this certificate of being readily biodegradable. And then in public opinion, bio-based polymers sometimes end up as being perceived as bad because people feel like, oh, but they don't degrade after all, but that's not technically true. And yes, with the building a new production site that I mentioned earlier, we have this issue, but this is probably more of a German topic, really, because of the regulation in place in Germany for actually building factories. So the, let's say, conventional plastics, they sort of have a 50 years head start in a way, because all of the production plants are already running, they have their permits, and they have everything optimized and established. And then that's sort of a huge barrier for new bio-based polymers to enter the market, to get these permits to actually produce. And yes, I hope I stayed in my time, but well, thank you very much for your attention, and I hope this was roughly understandable coming from a, let's say, German point of view on chemical industry. And yeah, thank you.
Thank you. It was great. Go ahead, Valentina. Sorry.
No worries. Thank you, Katrin. It was very interesting to have this perspective. So if you have questions for Katrin, please also write them in the chat. We will have a Q&A session at the end of this first case study session. So I don't know if Maria Giovanna is here or if we want to move with Serdia, and then because we know she's having some connection issues.
I'm here.
Oh, good. Super good. Thank you, Maria Giovanna.
No, I would take advantage that I'm here and go before I lost everything.
Are you going to share yourself or should I share for you, Maria Giovanna?
Yes. No, I can try to share it.
Perfect.
One
Thank you.
thing, I will switch off. Hello, everyone. That's my face. I will switch off the video so I have a better connection, if you are okay with it, okay? So let me share my screen.
Catherine, in the meantime, if you can stop sharing so we can see Maria Giovanna's screen.
Sorry about that. Let me see. Somehow it doesn't say I'm still sharing. Oh, I see it now. Perfect. Sorry.
Do you see everything in presentation
Yes.
mode? Okay.
Perfect.
So, good. Okay, let's start. This session is dedicated to PLA. I guess you know already the material, so I decided not to go into the details of how the material is made. Very quick introduction. I am Maria Giovanna Vetere. I'm Italian, and I'm based in Italy, but my company is based in the United States. And NatureWorks is a global producer of polylactic acid, which we sell with the brand name Ingeo that you will see in this presentation further. So our plant is based in Nebraska, in the middle of the Corn Belt, because our raw material is only sugar. So sugar, which is fermented, and then we get lactic acid from sugars. Lactic acid reach our plant, which is located in a big biorefinery in Blair, Nebraska. And there lactic acid is polymerized. Okay, so there are a couple of intermediate steps anyway. So we get lactide, and then the lactide are polymerized into PLA. PLA is a polyester. Let's say it's the big family of polyesters. As such, it derives from corn, and the title that I gave to the presentation is about the joint ventures. This because where we started to do this journey, and why sugar from corn, because the idea at the end of the 80s came from Cargill and Dow Chemical, who decided to work together to develop plastic, a polymer, which could be able to use the overproduction of corn that was available in the Corn Belt in the US. So what you see here, which is, these information are also available on our website, is really to explain which part of the corn we use, which is basically starch, that is used in many different applications. So it's a perfect example of how bioeconomy in practice can really foster innovation and also better use of land and feedstock in general. So we take care of the biomass. We have many certifications, so we are proud to say that we use sustainable biomass, as it was also highlighted by Plastics Europe before. I saw in a presentation that it was really pointing to the sustainability of the biomass. So as a polyester, you see that these are all the applications that we are working on. The markets, I just put there some examples. The markets are different. We commercialize our Ingeo in all areas, in the US, Europe, and Asia. And these are basically the applications. So rigid films, and fibers and non-woven, because it is possible to make filaments out of yarn and filaments out of PLA, and 3D printing filaments, which is a very nice and recent application. Now, going to the questions that I got from you guys. So to talk about the policy which are influencing biopolymers, and specifically bio-based and compostable, like PLA is, because PLA is also compostable, biodegradable, we saw before. the colleague sharing the biodegradation measurement. So these are, at least in Europe, at Brussels level, the policies that are at the moment influencing us most. So the policy framework for bio-based and compostable plastic, which is only a communication, but is already putting together all the elements which are, let's say, related with the use of bio-based and compostable materials. Then there is the taxonomy for sustainable economy, and this is more complicated because it's a very wide legislative body, but is not giving to bio-based material the credit that they deserve, I believe. Forest strategy, I could talk hours of all of them, but let's say that for us at the moment, we see the packaging and packaging waste regulation as the most recent and more important piece of legislation which is addressing bioplastic, because it's both tackling compostability and bio-based. And there is a promising article in the PPWR, because it's going to ask the European Commission to prepare a document which is, let's say, a legislative action with the aim of improve and increase the use of bio-based plastic and bio-based feedstock in packaging. So this is a very important one, and we will see how this will be put in practice. If the European Union wants to really boost the use of bio-based material and reduce the dependency from fossil-based plastic, it's clearly they clearly need to invest more and to do better legislation to push that. Our aim, because what we see, and this is what I think are the challenges and opportunities that are coming from legislation and, let's say, political environment, are really based on three pillars: the bioeconomy, the bio-based content, and the biodegradability. PLA specifically is a very versatile material, so it can be used in many applications, which comes together with opportunities, of course, because the market is wide, but also many challenges, because every specific field is requiring specific characteristics, and there is specific legislation that we need to comply to, so it's not that easy to adapt. Anyway, on the bioeconomy side, I think we need to improve the bioeconomy strategy. Europe has already a bioeconomy strategy, and many European countries have a bioeconomy strategy to really boost bio-based materials. And with bio-based, what I intend and what we intend as an industry is all those plastic where bio-based content can be measured using C14 radiocarbon. This is also stated by the European Commission, by the way, in the policy framework for bio-based and compostable plastic, which doesn't mean that use feedstock in a wide variety of other polymers doesn't make sense. It does make sense. I think it's important that the bioeconomy is boosting really the uptake, the use of feedstocks, sustainably grown biomass for the use of so we see that there are a variety of them, like the bioattributed that we've seen before, also in the Plastics Europe slides, which are really a big effort that plastic industry is doing to incorporate more bio-based feedstock and biomass in the production of the polymers. So what we would like to see in the bioeconomy strategy is removing, for instance, the limitations that they are. At the moment, the bioeconomy, the European bioeconomy strategy is talking only about marine biodegradable items, which is really reductive compared with the vast variety of material that is possible to make from biomass. And then again, as I said, support the bio-based content, not only in the PPWR and the packaging waste regulation, but also in the vehicles and the durables, and promote rule for the sustainable biomass. For us, this is a very important point. As a producer of PLA, which are based in US in the Corn Belt, we believe that it's very important to work on sustainable agriculture and to really promote the use of sustainable biomass, because intensive culture like corn can have a significant impact on the environment. So it's important that companies do their own homework, and our resin is certified. So it's important to go with the certifications for sustainable biomass, like it's also mentioned, by the way, in the European Directive for Renewable Energy and partially in the taxonomy. Finally, and that's my last point on biodegradable material, really give better support to the use of compostable plastics for food storage application in the case of packaging, and improve the fertilizer legislation and improve the microplastic legislation. So there are many points that really from the legislative point of view is possible to do. What I would like to see also is to, in general, address all the innovation that is not only my company, but in general, the bio-based plastic companies are doing every day. And at the testimony of this, there are the many bioeconomy clusters that are also in many different European countries, one of them being Germany, which has a very active and interesting bioeconomy cluster. Unfortunately, Germany is not really taking the bioplastic as a part of their growth strategy in general. So what I would like to see in the future is also to have some countries like Germany, like others, to really try to understand the value that they can get in terms of social benefits, in terms of growth, and environmental performance by using bio-based and compostable materials. So that would be it. I don't know if the sounding was working.
Thank you very much, Maria Giovanna, very interesting presentation. Now we go to the next speaker. It is Dirk Hölter from CERDIA.
Thank you. So first I will take the challenge to share my screen. So I hope you can see it correctly.
Yes.
Okay, perfect. So first a short introduction of who we are. CERDIA probably is not a well-known name. It's quite new, the name, but the company itself is already existing for quite a long time before part of Rhodia or Solvay. So we started to produce cellulose acetate in 1912. So currently there are about 1,000 employees in 5 countries, and the production is about 100,000 tons of cellulose acetate per year, and we are the only producer of cellulose acetate in Europe. Besides the cellulose acetate itself, we also produce filter tow, which is mainly used for the production of cigarette filters, which is also, let's say, the most known product currently for cellulose acetate. And the headquarters are in Basel in Switzerland. If you look in a nutshell on the value chain, okay, since it's a bio-based product, it starts somewhere from nature. So for our production, the main raw material is wood pulp, and what we do is acetylation with acetic acid to get cellulose acetate. And also, let's say, in our process, first step is the conversion of the cellulose acetate to fibers, mainly to filter tow. But we also sell cellulose acetate to produce of other products. And so the overall loop can be closed finally by biodegradation, because cellulose acetate biodegrades in more or less all different kinds of environments. But one target is also to have another loop, and this will be the reuse of cellulose acetate from products. I will come to this point also on the next slide. So we have seen most of this regulation and directive already in the presentations before. So let's say the ones impacting us most are currently the Single-Use Plastic Directive and also the microplastic regulation. And if you look on the challenges and barriers, although this was mentioned before, is so there is also no clear definition for bio-based plastics and biopolymers, and there are also no incentive if you are bio-based compared to fossil-based products. Another point is also the availability of bio-based raw materials, which is also somehow connected to the current policy within the EU. And coming back to the point of circularity, let's say the problem we see is if you would like to develop some circular process, it may be different depending on the product, on the marketing sector. And this is really challenged by the regulations because there is no differentiation between the various man-made polymers. All are considered as plastics. There's no bonus if you use renewable carbon, and yes, let's say the biodegradability requirements, if there are any mentioned, they are even very challenging for what be for natural materials. That's but something what we already heard before from Aminova. If we look on the environmental dimensions, what we are doing is, okay, clear, it saves fossil carbon feedstock. Then it will address many questions concerning the plastic pollution. If you talk about microplastics, because of biodegradability and non-persistency of materials. Then with cellulose acetate, not all bio-based polymers or polymers have the same properties, like sometimes it's impression if you look into the regulations. So each material delivers some unique properties. For example, for cellulose acetate, this would be also a high softening point. And what we are also doing currently is, okay, we support the development of circular economy, since we do some work and development in this case. If you look on the societal dimensions, okay, it will address the consumer demand for bio-based material. Then the sourcing is only be done from certified, let's forestry materials. And also local, we have integration with stakeholders and authorities. For example, we provide waste heat from our production for heating for us industrial partners, or even residential heating. And let's say on the last slide, there's not only the secret filter, which sometimes the impression that is, let's say, the application for cellulose acetate. There are many others, and not only the one you can see here on the screen. So, but let's say that the entry in many of these applications is somehow blocked, or at least they are hindered, at least in the European level currently, because of the SUPD and the microplastic restriction, where some be caught in between, because there's no, it's more or less all polymers, all man-made polymers are defined as a problem, not as part of a solution. Another point is currently also availability of bio-based raw materials. For example, we cannot get as much acetic acid as would be necessary for our whole production to switch to purely bio-based products. And then clearly we have higher production costs compared to, let's say, standard fossil-based plastics. And another point, currently there's not sufficient research into circular bio-based economy between the different stakeholders or producers. So that was it in a nutshell.
Thank you, Dirk. Very interesting presentation as well, highlighting many challenges that are also very, that need a solution as soon as possible. And now we go, first of all, if you have any questions, you can also write them in the chat, so we can provide you with the answers also during the either written way or also later, also maybe with some Q&A session. And then we go now to the other case study, is to the other case study that Circle will present. And we have basically the polypropylene from used cooked oil.
Thank you, Luana. I can share the screen.
Thank you, yes.
I don't know if you can see the presentation mode.
Not yet. Yes, now yes.
Yes? Okay. Well, in our case, we're going to talk about the PP from used cooking oil. I think it's easier that the name. And in our case, the bio-based polypropylene have similar characteristics that the standard polypropylene that provides from the fossil fuels. And it's created or it's manufactured from the materials as corn, vegetable oil, and sugarcane. These materials is one of the most used in Europe, and the growing demand for plastic have attracted attention as alternatives to try to replace the plastic that are created from petrochemical to the use of bioplastic with other type of things. The market is still at its nascent stage, and it's expected to increase the production of this type of bioplastic. And the market basically is in a lot of things, in buildings, in packagings, in automobiles, and other type of materials. We create our stakeholders mapping where we identify different stakeholders that can have a relation with the supply chains from the government, academias, civil society, and industries. In our case, we need to know the stakeholders that can provide us the oil, like household or restaurant, the industry that can transform the oil to plastic, and the plastic manufacturing companies to transform the end product that's going to be used by the users. The policies that have relevant in this case are plans like the circular economy plan that is part of the European Green Deal that provides a circular economy process considering the entire life of the product. The plastic strategy that the aim is transform the way plastic product in all cycle life. The EU policy framework that consider bio-based, biodegradable, and compostable plastic. And at national level, we have the circular economy strategy that consists of the aim is the recomposition of raw materials to be transformed in raw materials and obtain a product. Another important thing in this case is the waste and contaminated soil law in Spain, because we are considering the use of oil in the use this oil like a raw material to produce the plastic. The most relevant indicators that we identified are on environmental level, the waste generated, in this case the oil, the life cycle, to now the emission that have the product that we're going to make, economic indicators that cost of production and the return of the investment, and social indicators like the number of informal workshops to try to inform the process of produce this material and the quality of the employment. It will increase this type of industries. In this case, we don't have a net species, so we identified policy, economic, and environmental dimensions. At policy dimensions, we identify the problem or the barrier is the market regulation. Industries such as packaging or automotive demand consistent performance. At economic dimension, the production costs are higher produce this type of materials than the use of petroleum-based plastic. Is inefficient research into a circular bio-based economy. And at the environmental and social dimension is that we use plants to produce this type of plastic. Exists a competition between food and soil. And in case of the use of oil to produce this type of plastic, we are trying to reduce the use of waste or the accumulation of waste and reduce environmental pollutants, in this case, the oil. That's all from my side, and thank you very much.
Thanks, Carlotta, for this great overview. I think that after this the overview from our experts, but also thanks to our teachers and experts for providing their specific view. I think we can move to the interactive discussion, so with all participants to the workshop. So we will ask you similar questions we asked to our teachers to respond to. But first, I let Luis introducing you the technical usage of the Miro board. So I put here in the chat a link. So from your laptops, you can click the link and enter this Miro board. Luis, I leave you the word for the technical introduction here.
Thank you, Valentina. So to use the Miro board, you can use your mouse to, with a wheel, if you have a normal mouse, to zoom in and zoom out. If you don't have a mouse, you can use the tool on the bottom right corner. There is a zoom tool. You can scroll by clicking with the right of the mouse screen. And in order to add your contribution, you can just pick one of those sticky notes that Valentina is going to explain later, and just move it in the area where you want to add the contribution, and double click and write your text. Valentina?
So thank you, Luis, for the introduction. Keep in mind also that if you have troubles in using the Miro board, you can use the chat indicating if you're referring to challenges, good practice, recommendation, or policy context, or you can also speak up. So we are happy also to hear the voices of our participants for sure. So what we are asking you to in this Miro board is to collect the challenges regarding these 3 dimensions, so the policy dimension, the sustainability dimension, and the market dimension. So to collect your specific challenges, we already heard about some challenges from our experts during the pitches, as said, but you may have some other challenges to be shared. And we are also very interested in understanding your good practices to respond to specific challenges or recommendations. We heard, for example, before from Maria Giovanna, some recommendations in terms of policy to transition, no, to more sustainable plastic sector. So if you have, of course, good practices already in place or other recommendations in these 3 dimensions, not only on legislation and policy side, but also on more sustainability, so environmental and social dimension or market dimension. And finally, if you have also other policy contexts in which you are moving as plastics producer or plastics actors in the value chain, let's say. As said, Luis already said, you can use the different post-its with the different colors if you are referring to challenge, good practice, or policy context. So red for the challenges, green for the good practices or recommendation, and blue for the policy context. So while you are moving through the Miro board, starting inserting your specific inputs, and thank you in advance for these are very, very important for SASTRAC research and to produce policy recommendations also for the transition. I don't know if someone has some questions, since we didn't have time before to have the Q&A session specifically, but if you have pressing question, feel free to write them in the chat or speak up. So now it's the time also to our teachers or to our experts from the project. If you have any question,
yeah, if you want
you can also
you can raise your hands so that we can call you and to speak.
I have already put the question from Patrick in the Miro board. So I don't know, Patrick, if you want to elaborate a little bit on your challenge, basically. That is about harmonized test methods to assess biodegradability.
Yeah, absolutely. So in general, we see that there is so far not a harmonized system, as Catherine already introduced about the assessment of biodegradability. And that would be very helpful to provide harmonized test methods that can be somehow or compared to each other.
Patrick, and then you said,
Yeah.
I think we lost you,
Yeah, I think we
Patrick, in
lost
a
Patrick.
certain point. Meanwhile, Patrick is back. I don't know, Luana or the other.
No, I was just saying
technical-
because I wanted because Patrick said about biodegradability, but also about eco-efficiency, other parameters. So he wants to elaborate more on this, but I don't know if he was not done yet with this.
There is Tatiana that raised her hand.
Yes.
Yes, hello. My name is Tatiana. I'm from Finland, to be specific, in the northern part of Finland. And we have a project with Norway and Sweden in the northern part to creating the mutual waste management business. And my question to all of participants, when we speak in the conventional plastic and bioplastic, from the point of view end user, how to sort it, how the customer will sort it in the end of life, and maybe you have insight about the not recycling, but at least sorting problems. Is it a problem, not a problem, labeling, and so on?
Somebody wants to answer the question? Maybe also. I see we have European Bioplastic here because they've done a lot of studies on this, also maybe on the communication challenges and also what is a bio-based plastic and so on. Maybe somebody wants to say something on this. I see the Innova Institute also doing a lot of studies on this.
Feel free to speak up, the people that are cold, so you don't have to raise your hands, open the microphone and speak up if you are cold by...
Hello, sorry, this is Loretta Brea from European Bioplastics. Apologies, I'm at an airport, so not sure if you can
Sorry, yes.
see me maybe. Yeah, we are studying this, the sortability, recyclability of biodegradable plastics at the moment. It's potentially too early to comment.
At my point may be open question, but we are going to maybe elaborate in our project on this topic as well, because the waste management facilities and operators, for them is could be the challenge in the future, and we just want to make the recommendation or suggestion how they need to look up on this problem. So I think the last part of life of the product is the same has the same importance like a design. Just a comment.
George?
Thank you.
Alaska has a raised hand.
Yes, hello.
Hi,
Thank
George.
you. Hi. So I'm quite new to the sector, so what I may be saying is kind of a semi-outsider's perspective. But from participation also across the last workshops and also this one, and in the context of our company, I am having the impression that we somewhat have a chicken and an egg problem. It seems to be like this. So what I'm saying is, on the one hand, we are focusing on the production of bio-based plastics and biopolymers, and the producers of those resources are facing the challenges with regard to the regulations, microplastic directive, biodegradability on the one hand. But on the other hand, what would also be required for us to kind of move into the somewhat more sustainable track is the availability of biogenic feedstocks. So the primary raw materials in our instance, for instance, I think acetic acid, that would need to come from renewable sources in order for us to move further into this direction. But from the producer point of view, there doesn't really seem to be the incentive to move forward to in that direction because it's uncertain whether the demand is there. And on the other side, on the producer of biopolymers, the demand cannot really be generated because there's this shroud of regulations that are not specific enough to provide certainty for also ramping up investments. So that's my perception of things. I'm not sure how well this is founded in the research, but I just wanted to contribute that also because I had this impression that on the one hand it should be scaled up, on the other hand neither the producers of primary raw materials nor the ones producing polymers are really willing to act because of this deadlock with regard to regulations.
Thanks.
Thanks, Georg, for this input. I see that the Miro board is filling up with all your contents, many challenges I see, and not so much recommendations or solutions. I also kindly ask you to, if you have any good practices already responding to some of these challenges, to let us be aware about these challenges, and also if you have specific recommendations and not only challenges to overcome these specific challenges.
Just to answer a little, to give an insight to the previous discussion about the recyclability of bio-based plastics in general, because the end of life that is preferred also by the European Commission is really to limit to biodegradability to certain conditions, but there is also a very, very interesting analysis from Nova Institute that I think they are somewhere around. And in any case, there are a lot of multi-stakeholder debates all over Europe to also involve the people that are working in a recycling facility in order to understand what is needed for them to recycle bioplastics together with the other plastics, so to separate and to recycle it. So there is a big debate in Europe about those topics, and there are several projects also focusing on it. So of course is a hot topic on the table, and so just to give you this perspective of what is going on.
And just to add to this, we did another study once with the PPF project, Stafford WBI, and basically, especially in Germany, for example, also in the Netherlands, the problem was that bioplastics are not so welcome because of the running facilities for the waste management. For example, the time for like the standards needed to be revised for biodegradability, for example, because it requested 12 weeks, I think, for the biodegradability process. However, they don't run the facility so long. So there was a problem also on somehow adapting the facilities to the standards. But I think, if I'm not wrong, the standard has been updated, or they were going to update it. So we hope that this one will somehow maybe improve the situation. But I remember in Germany, we have also a problem because each federal state has a different regulation or different also waste management facilities. And somehow I think the bio-based plastics are not very much welcome yet. So there is also a problem, not only with the regulation, but also with the infrastructure itself. And so, and the idea is also to see what can we do in front of these challenges. Of course, as we said, regulation can play an important role, but also what can we do in order to update the waste management infrastructure, for example. So,
remembering that there are two main streams. One is the composting facilities, and the other one is the recycling of bioplastic. That is also an answer to the availability of raw material, because they go back in the loop. So, but I see that Patrick is back. So Patrick, maybe you would like to keep on finalizing what you were saying. Apparently it was back.
I tried again. I have some issues with the internet today. So in general, we see that there are several different ways to measure the biodegradability. And when we're talking about biodegradability, compostability, we need, of course, to have harmonized systems in order to making sure that we can compare the different properties of the products in the right way, and also to give a better understanding under which conditions our plastic becomes biodegradable. And this is from our point of view very important, not only for plastics that end in the environment, like in the agriculture sector, but also in medical devices, for instance. So, for instance, the screws that fix broken bones, they should also biodegradable, or in order to making sure that we have the chance to compare these methodologies. In addition, it's very important for us that we always have the chance to compare the bioefficiency with each other. So harmonized life cycle analyses are very important for us, because we see that, so for instance, when you have bio-based, the claim bio-based, it can be come from bio-waste material feedstock, like used cooking oil, for instance. However, in many cases, we are talking about castor oil-based products, palm oil-based products, that are certainly not as eco-positive compared to those materials. And therefore, we also need to have transparency along the value chain, along the supply chain, to making sure that we are talking about bio-efficient, bio-positive feedstocks that end in bioplastics.
Yeah, thank you, Patrick. I think this links very much to what the comment of Paula is referring to certification, because as you said, improved transparency along the value chain, this one requires maybe a harmonized method to do this. So how can we make sure that we can really provide the positive impacts of the use of sustainable bio-based resources? And the question is, do you think the certification schemes could support to promote the market uptake of bio-based plastics? And does somebody want to elaborate on that, on the certification schemes, maybe? As Paula said, there is a cost, of course, of getting the product certified, but as you hear from Naturworks today, all their product, the feedstock they're using is all certified, and that is an implication on the final price of the product. Of course, it's very interesting to know. So the question is, how can we make sure that we can use certification schemes, but on the same way also like find a way to really implement them, because they are all, as we know, bio-based is more expensive than fossil-based. And if we also need to provide the expensive certificates, this one will also further increase the price of bio-based products. So how can we maybe find a way around this? What can we do in order to maybe, I don't know, for example, one way could be to ask sustainability for all products. So also fossil-based plastics should be certified in the same way as bio-based plastics. And I don't know, any other ideas?
Yeah, it's a matter of shared of custody. So we need transparent we need to have tools that provide transparency along the chain of custody. And this is something we're discussing at different levels at Plastics Europe, at CEFIC, and so on, because we are also talking about the competitiveness of our European industry compared to Asia and the US as well.
And Patrick, do you think that the new legislation on eco-design, like the idea of having a DPP, will help this, like a digital product passport? Do you think this one is a good instrument to really provide a solution to this problem? Like we need more transparency in the chain of custody. Do you think the DPP, internal DPP, will help this? What do you think?
Yeah, this is of course a very important tool once it is established and it works. However, yeah, it's a long way.
It's a long way. Yeah, I agree with you. But it's a good start, no? It's a good way to really, like the intention is very good. And of course, the good way to go. Any other comments on this? We see like the Mareike wrote that, of course, there is different documents for the paper plastic on this. There's one on standards and the use of standards. And I don't know if you want to say something on this, or there was a problem with the connection, I think, as well. Yes, but
Yes, if
yes.
any other of our experts who intervened today, but also not, has something to add on this, please feel free to speak up also, because we are going towards the end of the workshop. So these are the last occasions. Yeah, Dirk.
But maybe one remark concerning the biodegradation. So let's say for the definition, there are many standards on biodegradation also of plastic materials. But one problem is, let's say the limits which are set after which time it had to be biodegraded to see an advantage. So currently, if you look at the microplastic restriction, there are the limits given there. This is more compared to a very, very fast biodegrading material like cellulose. And even if in one test, it takes you 100 days instead of 60 days, then you are not considered as really biodegradable, and this makes no sense. And there's no, let's say, there's advantage for the environment. That's clear.
Yeah, and this one goes to the discussion that we said before about like also the costs, or like the cost and benefit for the composting facility, because if they run the process like too long, so they don't want to do that. So it's linked to this. Yeah. So the idea is, yes,
I think it's a difference between a composting facility and if something will biodegradability in the sense if it will end up somewhere in nature for any reason.
But if it is unintended, is something. If it is a kind of products that, like, for instance, fishing gear, in which you have to ensure also durability, is another problem. So I don't know if you are also facing this question, but if we want to give a product that is similar to plastic, we also need to have the same performance to be accepted by the end users. So do anybody have an idea also on that? Okay, so I think that there are some other issues in the Miro board, but is maybe not very easy. I don't know if the technical partner would like to pick something. And to make a focus, there is something about awareness and working with the consumers to raise their awareness, but also not only the consumers, but also the end users, namely, for instance, fishermen or primary sectors. To make another example, there are other issues related to the cost, to the need to do multi-stakeholder research. Also, this is an interesting point. I think we are getting to the end. The only problem. Go ahead.
As my computer is not working anymore. However, I have just one remark. We are, of course, talking about circularity, and this includes also the recyclers. And therefore, I would appreciate if you could also invite recyclers to the meeting, to the workshops, in order to making sure that we get the perspective also how bioplastics or specialty plastics can be recycled, because today they are simply collected or separated from the mainstreams and then incinerated. So, we do not have an environmental benefit of when we simply use defossilated plastics that are simply incinerated after use.
Yeah, it's a good point to also involve. Of course, we try to. It's a good idea to involve also the waste management stakeholders, and of course, it's a bit challenging. But I agree with you, because how can we make sure that the end of life of bioplastics is treated in the proper way so that we can really integrate them in the system. That one is a key point. So as we have seen today, so we have different problems or challenges linked to the different value chain step. Also, sustainability is very important to make sure that we have sustainability of the feedstock used for the bio-based plastic production. And also, of course, looking at the production, make sure that all the environmental challenges, all social and economic, are considered. And also going at the end of life is very, very important to make sure that bio-based plastics are treated properly and they are accepted also in the different recycling facilities. And so I think we are coming to an end. And however, we will, if we have, yes. Sorry. So if you have any also further comment on or some for the discussion, we are also very happy to receive receiving your comments via email and questions, and we can, of course, we will share with you some minutes. And thank you for your participation. So I will give back to Valentina now for.
Thanks, Luana, for making this wrapping up. As you were saying, if you're interested to share your experience, you can, I put in the chat the email of our experts that you can reach out. And also we will keep the Miro board open. I see that there are many new contributions in the Miro, so we will analyze them and we'll go back to you with all your outcomes and contributions in our plenary session in September, where we will share the results of this workshop, but not only, also of the other 3 workshops in the other 3 sectors. So we will make sure to give you all the information via email and in our website and social media. So please follow us there also. And with this, I think we can close these workshops. Thanks again for your contributions, to our teachers for their availability and interesting talks. Have a nice weekend, everyone, and a nice summer break also. And thanks a lot also to our SASTRAC experts who did a very great job in building all this workshop. Thanks again, and have a nice day.